Hello my dear students, welcome back to ASM Math tutorial. If you are not subscribed to ASM Math tutorial, not yet, kindly subscribe our channel so it's motivate us to do more and more videos. Now in this video we are going to discuss about very interesting topic and very important topic in engineering, that is probability. Probability distributions and some few problems on probability distributions we are going to start in this series of videos. Now I'll begin with probability. What is probability? What is the importance of probability? What is the purpose of studying probability? We should know. See, usually in everyday life, knowingly or unknowingly, we use probability. Okay, suppose what we call it as when a student come to the college campus, he has two mindsets. One is whether I have to attend the class or I have to go for extracurricular activities. So he has confusion. So that means he has two possibilities, either come to the class or extracurricular activity. That means in general probability means what? Possibility. Probability means what? Possibility. So, how to define this probability? What are the prerequisites to define probability? Everything will go one by one. So, to go with probability, we need some prerequisites. What are those? First important thing we should know, what is random experiment? Random experiment. So what is random experiment? An experiment, when it is conducted, the outcomes cannot be predicted. Okay? If an experiment is conducted and if we are not able to predict the experiment outcomes, then that is referred as random experiment. For example, when we toss a coin, what happens? There are two possibilities. Either head will come or tail will come. So we cannot predict the exact outcome. Only head only will come or tail only will come, like that. Okay. So random experiment means it is an experiment in which outcome cannot be predicted. In other words, if we can say random experiment, it is an experiment which has more than one outcomes. So that is referred as random experiment. Then random variable. So what is random variable? See, you can see here random experiment, random variable. They are interlinked. If we know random experiment, then only we can define random variable. Means every outcome of the random experiment is referred as random variable. Every outcome of the random experiment is referred as random variable. So random variable plays a major role in probability distribution functions. Okay, so therefore we have to know what is exactly random variable. Random variable means it is the possible outcome, or every outcome of a random experiment is referred as random variable. Next, sample space. What is sample space? It is very simple. See, as we know, random experiment has more than one outcomes. Okay. So, if it has more than one outcomes means, suppose 3 outcomes are there, we'll write all the 3 outcomes. If 4 outcomes are there, we'll write all 4 outcomes. If 5 outcomes are there, we'll write all 5 outcomes. The set of all possible outcomes is referred as sample space. Okay, this is also one of the important concept, sample space. So what it says, it is the set of all possible outcomes of an experiment. That is referred as sample space. Then every outcome is referred as what? Event. Every outcome of an experiment is referred as event. Okay, so these are the basic prerequisites for probability theory. After this, we'll move on to Probability definition. What is probability? See, usually probability is denoted by small letter p. It is denoted by small letter p. So what it says in the standard form of mathematics, number of favorable cases divided by total number of cases means outcomes. Probability is nothing but number of favorable outcomes divided by number of total possible outcomes or total number outcomes. So you can call it as outcomes also. Instead of cases, you can call it as outcomes also. Okay? Probability means it is the number of favorable outcomes divided by total number of outcomes. So usually it is denoted by small n divided by m. You can interchange the notations, it is only for our convenience. Okay? So m indicates number of favorable outcomes, m indicates total number of possible outcomes. For example, if I toss a coin, what happens? If I toss a coin, I have two possibilities. What are those? Head may turn out or tail may turn out. In the same way, when we throw a dice, there are 6 possibilities. Because they have 6 faces, 1 to 6 numbers are there, 6 possibilities may there. Okay? Therefore, you should remember probability means this. Then Q. Q is nothing but probability opposite term. Okay? So P plus Q is nothing but 1. P plus Q is nothing but 1. In most of the cases, what happens? P indicates probability of success, Q indicates probability of failure. So probability of success and probability of failure together it is 1. The sum should be 1. Okay? So this is about probability definition. Once we learn probability definition, we will move on to some other important terminologies in probability. What are those terminologies? We'll go one by one. Exhaustive events. Exhaustive event. What is exhaustive event? All possible outcomes of an experiment is referred as exhaustive events. All possible outcomes of an experiment, they are referred as exhaustive events. Okay? Then we have mutually exclusive events. Mutually exclusive events. What is mutually exclusive events or what are mutually exclusive events? To define mutually exclusive events, we need at least 2 events. If any 2 events are said to be mutually exclusive, the happening of one event can prevent the happening of other event. Then we can say that they are mutually exclusive. In other words, the occurrence or non-occurrence of one event can prevent the occurrence or non-occurrence of the other event is referred as mutually exclusive event. For example, when we toss a single coin, so what happens? When we toss a single coin, turning out head prevents the tail. Okay? Turning out tail prevents the head, because when head comes, tail may not possible. Or when tail comes, head may not possible. So they are mutually exclusive. Mutually exclusive means what? The happening or unhappening of one event can prevent the happening or unhappening of the other event, or occurrence or non-occurrence of one event can prevent the occurrence or non-occurrence of other event. They are referred as mutually exclusive event. Then we have independent events. Independent events. So what happens? Independent events, it is opposite to mutually exclusive. So in mutually exclusive, one event can prevent the other event. But in the independent, it is the name itself it is there. The happening or unhappening of one event does not prevent the happening or unhappening of the other event, or occurrence or non-occurrence of one event does not prevent the occurrence or non-occurrence of other event. So instead of tossing a single coin, if we toss two coins, what happens? Getting head in one coin does not prevent the getting tail in the other coin, because they are independent events, both are separate events, they are not interlinked. Such events are called independent events. They are called independent events. So if I consider any two events A and B in the standard form, if I want to say these are independent, then how to define? The occurrence of one event does not prevent the occurrence of other events. Okay, I hope it is clear. So these are the basic terminologies with respect to probability. So we started with random experiment, random variable, sample space, event, then mutually exclusive event, exhaustive event, and independent events. So other than this, what we have given probability definition also. Then I'll just move on to mean. So before that, I just take one more important term: discrete random variable. What it says or what it means, discrete random variable means a random variable can take finite number of values or countable infinite number of values. A random variable which consists of countable number of values or countably infinite number of values, then that variable is referred as discrete random variable. Now we have one more important term called probability function. So what is probability function? See, I have an experiment. For that experiment, I have some set of values with respect to xi, and the probabilities also. We have p of xi. So what is probability function, or when we say that this event is said to be a probability function, only if all values are what? Positive, or p of xi values are positive or zero. I'm not to take summation here, I just simply write all values are greater than or equal to 0 and their sum is equal to what? 1. If these two conditions are holds good for any distribution function, then it is referred as probability function. So these two are very, very important. So how to write probability distribution? Let me take one simple example. Tossing the coin twice. So what are the possible outcomes? See, I write in the standard form S. S is nothing but sample space. So when we toss a coin twice, possible outcomes are both the times head may appear, head and tail may appear, tail and head may appear, and both tails are appear. Because when we toss a coin twice, 4 possible outcomes are there. All 4 possible outcomes are written. Now, suppose if X indicates, I'll just take here, X indicates no heads at all. No heads at all. I am considering probability of hitting head in this experiment. No heads at all. So what is this? As per the probability definition, the total number of possible cases are how much? 4. Okay, because 1, 2, 3, 4. And what is the favorable case here? No heads at all means we have only this. Tail. How many that is? 1. So it is 1 by 4. Then probability of only one head. Only one head. How many possibilities are there? So total possibilities are 4. Favorable possibilities only one head. This is possible, one head is there. This is possible, one head is there. So therefore favorable cases are 2. So 2 by 4 is what? 1 by 2. Then 2 heads. 2 heads. Probability of getting 2 heads. So what is the probability of getting 2 heads? Probability of getting 2 heads? Only one option. Head and head. Okay. So favorable case is 1. Total number of cases are 4. So if I write this in the form of distribution, then that will refer as probability distribution. So these are xi, these are p of xi, and you can see here 0, 1, 2. So no heads, 1 by 4, 1 head, 1 by 2, 2 heads, 1 by 4. Okay, so this is one simple example I have taken. Now, once we came to know, or once we perfect by writing probability distribution, we will move on to how to find out its mean and variance. How to find out its mean and variance. I'll just give the formula to find out mean and variance of probability distribution. Remember, here I am discussing discrete probability distribution, not continuous. Continuous I will discuss in the coming sessions. Now, what is the mean? Mean of discrete probability distribution. It is usually denoted by mu. Okay? Mean of the probability distribution, it is usually denoted by mu. And what is the formula for this? Summation xi p of xi. Xi into p of xi. And variance, it is v. So what it says? Variance summation xi minus mu whole square into p of xi. So this way can express in the alternate form also, but it is okay now. It is the standard form. We can follow this. So mean of probability distribution is summation xi into p of xi. Variance of probability distribution is what? Xi minus mu whole square into p of xi. So one more term will come, that is standard deviation. It is usually denoted by sigma. Standard deviation is usually denoted by sigma. So what it says? Okay, square root of variance. Standard deviation is nothing but square root of variance. So these two are very, very important. My dear students, in probability, analyzing the data, analyzing the problem is very, very important. Because here no integration, no calculus, nothing. Everybody can easily solve the problems. So, but the thing is, you have to remember all these basic formulae and the data and the theory part what I have discussed so far. So that you have to remember. Okay. So based on this, I just take one problem and we can solve that problem. So what is this problem? I just take. So I am just going to solve basic problems, since because introduction class for probability we can take basic problem only. So what it says, problem: a coin is tossed. The coin is tossed twice. The coin is tossed twice a random variable x represents the number of heads, x representing number of heads turning up, number of heads turning up, find discrete probability distribution for x, also finds its mean and variance, very basic problem, simple problem. Okay, so we'll move on to one by one solution. First, you see, a coin is tossed twice. When we toss a coin one time, we have two possible cases. When we toss a coin two times, we have four possible cases. When we toss a coin three times, eight possible cases. That means when we do any experiment n times, so the possible cases are 2 power n with respect to coin. Now, I write the sample space. Sample space S equal to, the possible outcomes are what? Head, tail, head and tail, and tail and tail. Okay. So now, if the random variable x denotes the number of heads turning up, because the question is heads turning up. So what happens? Probability of no heads. So here total number of cases are 4. The favorable case with respect to no head is only 1. So it is 1 by 4. Now probability of getting only one head. So total number of cases are 4. Only one head means 2 heads are there, not possible. 2 tails are there, not possible. Only one head means this is possible. Therefore our favorable cases are how many? 2. So if I solve it, I'll get 1 by 2. Then probability of getting 2 heads. So probability of getting 2 heads, how many possibilities are there? Only one head is there, 2 tails are there. So probability of getting head twice, when 2 times, it is only one possibility. So that is 1 by 4. So using this, I would write the distribution table. So these are the basic data to write the distribution table. So if I write distribution table, so what happens? This is xi and this is p of xi. Xi is random variable, no heads, only one head and 2 heads. What are the probabilities we are getting? 1 by 4, then 1 by 2, then 1 by 4. So distribution table over. Now we have to apply probability function conditions or probability distribution conditions. We have to check whether it is a probability function or not. So what is that? P of xi should be what? Greater than or equal to 0. You can see here, greater than or equal to 0 means any of the P of xi value should be 0 or positive. If any one is negative, we can't write. Now 1 by 4 positive value, 1 by 2 positive value, 1 by 4 positive value, all P of xi's are greater than 0. Therefore, this condition holds good. Then sum of P of xi, summation of P of xi should be 1. Now check, 1 by 4 plus 1 by 2 plus 1 by 4. So what happens is 1 by 4 plus 1 by 4, it is 2 by 4. 2 by 4 means 1 by 2. 1 by 2 plus 1 by 2, 1. Therefore, summation of P of xi is also 1. Both the conditions are whole squared, so it is probability function. Now we are going to find out its mean. So what does mean? Mu. So what is the formula we have? Summation xi into P of xi. So what it indicates? Summation means you have to take every value of x with every value of p from the distribution table for all the values, and we have to add them. The first xi value is 0 into 1 by 4 plus second xi value is 1 and their corresponding p of xi is 1 by 2. Next it is 2 into the corresponding value is 1 by 4. So if I simplify, what happens? It is 0 into something 0. It is 1 by 2. 2 into 1 by 4 again 1 by 2. So answer is 1. Because half plus half is 1. Now I have to find out variance. So variance P equal to, I'll just write here because the space is not enough there. I don't want to here. I'll just write here. What is variance? Summation xi minus mu whole square into P of xi. Mu we already established, that we have to write. So P equal to, summation means you have to take all the values of this distribution table. What is the first value of x? 0. This is 0. Corresponding mu value. Mu value is what? 1 into P of xi, that is 1 by 4. Okay, this is square. Plus second xi value is what? 1 minus 1 whole square. Their corresponding mu value is what? P of xi is what? 1 by 2. Next 2 minus 1 whole square 1 by 4. Because this is 1 by 4, P of x. So if we simplify, we will get mean. What happens? Minus 1 whole square means what? Plus 1. 1 whole square means 1. 1 by 4 is 1 by 4. 1 minus 1, 0. 0 into something 0. 2 minus 1 whole square means what? 1. 1 into 1 by 4 is 1 by 4. So it is 2 by 4. 2 by 4 means what? 1 by 2. So therefore variance, what happens? Variance equal to 1 by 2. Once we find out variance, we can easily find out standard deviation. Standard deviation sigma equal to square root of b, that is square root of 1 by 2. So this is how to construct the distribution table with respect to the given data. Then how to find out mean and variance of that particular data, everything. Since it is the introduction class, you have to go through all the definitions and mean, variance, standard deviation. You just try to solve this one example. So in the next class we'll do some more problems based on the distributions. I hope you enjoyed this video. Again I am requesting, if you are not subscribed my channel, kindly subscribe and encourage others also to subscribe and share this video as much as possible to help the student community. So thank you all. We can meet with next video.
ಬಂದಿದೆಯಾ ಇಲ್ಲ